Hey, what's up? In this video, we're looking at different ways to display data, and there are quite a few, and we're going to look at 5 really popular ways that people display data. So the first is going to be a bar graph, and let's go over everything you need to know about a bar graph. So a bar graph is good for comparing items and data over time. It often can be used to also separate things by age group, product, or gender. Just anything you're segmenting by group, bar graph is a good way to do it. And when you're doing a time-based bar graph, time is usually displayed on the x-axis. So let's go ahead and look at some examples of bar graphs. So this one is an example of Meta, aka Facebook's revenue per year. So again, you got years on the bottom from 2012 to 2021. And then you have their revenue in billions of dollars per year on top, from 10 all the way to 60 is the highest on this graph. So if you look at that legend over there, Facebook ad revenue is in blue, and that's like Facebook.com. Instagram is in pink. WhatsApp is in green, and Oculus is in yellow. So let's take a look at all these. And so from 2012, there it's just Facebook is the only revenue they have. And the 2021, they have now 4 segments of revenue. So from then 2012 to 21, as you can see, the general trend line of the company is up. But if we just look at just Facebook, it's kind of plateaus. It's still going up, but not quite as much around 2021 as it was in earlier years. Let's look now at Instagram in pink. Instagram is going up, probably is growing a little bit faster than Facebook. So you can see the area in pink is gaining on the area in blue. WhatsApp next in green. And again, WhatsApp growing pretty much as fast as Instagram, where you can see it's really starting to take a bigger chunk of that revenue. And then Oculus in 2018, if you look, it's just a little sliver there, but it is growing very fast. It looks like it's almost doubling per year as you look at how big it went from 2020 to 2021. So you would think by looking at this chart, good things to come for the Oculus segment in the future. Another way you can use a bar graph is when you're segmenting by age group. This is U.S. COVID deaths by age group since COVID-19. I know, kind of a rough topic, but it is a good representation of how things can be broken up using a bar graph. So on the bottom, you got number of deaths, and then on the y-axis, you have age group, and again, first age group is 0 to 17, and then the highest age group is 85 years and older. And then that gray chart line at the top right there, that is if you tally up all those columns, all those little rows, it will all add up to 1,056,000 up there. So let's take a look at what that looks like. So if we're to take all those age groups and just put them on one big line, it will cover that gray line. So I'll show you what I mean right there. So there we go. And yep, that's it covers the gray line. So we know that all those segments, they total all that 1,056,000. And so that is 2 examples of a bar graph. Let's move on now to a pie chart. And it's called a pie chart just because it's in the shape of a pie dish. And pie charts are best for breaking things down by percentage. And so one thing to note about a pie chart is everything within a pie chart has to add up to 100%. It has to be a full pie chart. So I think pie charts are the easiest to read, the most straightforward. And again, this is an example. It says a poll of 500 students ages 14 to 18, their favorite social media platform. So again, you see YouTube in purple, 35% prefer YouTube. TikTok in blue, 25% prefer TikTok. Instagram in green, and 18% prefer Instagram. 12% prefer Facebook, and Twitter in red, 10%. So very straightforward. All of those percentages add up to 100. And again, YouTube is clearly the most favorite of this group, and Twitter is the least favorite. This graph's looking at world population by country. And again, the total, if you're to add all up all the countries, 7.735 billion. And so really this chart, if you look, it's only tracking 4 countries. uh, China, India, US, and Indonesia. Every other country is lumped into that rest of the world category. And so the rest of the world is 4.49 billion, and that's going to be 57.88% of that 7.735. China is the biggest country in the world by population, with 17.5% of the world's population. India not far behind, 17.1%. Big drop off from India to the US, which is the third biggest at 4.12%. And then Indonesia is the fourth biggest at 3.4%. So if we tally up all of these percentages, add them all up, it's going to be 100%. So again, we know that the pie graph is good. So those are pie graphs or pie charts. Now let's move on to a line chart. Line charts are good for examining trend lines over time, similar to bar graphs. It's a lot of the time it's a matter of preference, but line charts are better than bar charts for tracking smaller changes, like percentage growth. So if you want to track smaller changes, usually a line chart is an easier visual for us to understand. So this line graph is looking at global adult literacy rate from age 15 and older from 1976 to 2019. It breaks it up by gender. So again, as you see, you got year there on the bottom, and then you have literacy rate on the y-axis. And whenever it's something like rate, murder rate, literacy rate, mortality rate, it's always out of 100. So 100 is the highest possible literacy rate a country could have, and it just means the percentage of the country that can read. Or the percentage of, in this case, the global population that can read. So again, if you look at that blue line is overall, that's if we combine everybody literacy rate in the whole world. And so again, that starts there and goes up. Male literacy rate is in black, and that's right there. And female literacy rate is in gray. And as you can see, male literacy rate in 1976 was much higher than female, but the female literacy rate has grown a lot more, so now they're a lot closer. And that blue line is right directly in the middle because it's taking the average of both. So that's one line chart. Let's look at another one. This one is looking at price changes in selected U.S. consumer goods, services, and wages. And it's from January 2000 to December of 2020, so 20-year gap there. And so a few things to look at this. So first, if you notice that it's got that overall inflation, that line right there is overall inflation, so the average inflation in that 20-year period. And then at that bottom, that's 0%. So if something was at 0%, that just means that the price has stayed the exact same since 2000. So those are the two lines we're judging off of. And then if you look at our color key, dark red and light red, and they only did that, it alternates, so you have a dark red, a light red, a dark red. That means the price has gone up more than average inflation since 2000. And then you have the dark blue, light blue. It's the same thing. They only separated them just so you could alternate, and so it goes dark blue, light blue, dark blue, light blue. And those mean that price has actually become cheaper since 2000. So you can see stuff like computers, toys, TVs have gone actually cheaper in price, but big stuff like hospital services, college tuition, college textbooks have gone way, way up since 2000. So those are line charts. Now let's look at a histogram. And a histogram is best for measuring frequency. And it's often displayed with frequency measured on the y-axis. And histograms are often the step before you create a standard normal distribution. So let's take a look at a histogram example. So in this one, it's looking at the distribution of salaries of the employees of the ABC Corporation. So you have the salary range in thousands of dollars on the bottom. And then you have the frequency or the number of employees in that salary range on the y-axis. So again, you look at that first salary range, it's 0 to 10. That means employees that have made 0 to 10,000, and it looks like there's about 50. And then on the far end, you got 90 to 100,000 is the biggest range, and it looks like maybe 25 or 30 employees in that range. The biggest range right there is in the middle, and it's that from 40 to 50,000. And it's the biggest because if you look at the chart and you draw a line over, that means this the highest number of employees in that range. So again, in this case, it means if you look at that, it looks like about roughly 550 employees at ABC are paid between $40,000 and $50,000 per year. And so again, that is a histogram. Remember, it measures the amount of times something happens or the amount of people in a certain range. And it's not a perfect bell curve, this one, but you can see it kind of has that bell curve shape to it. So that's a histogram. Now let's go over our last one, which is a heat map. And heat maps are best for measuring phenomenon by region, and is often used when trying to compare something that happened by geographical location. It can track weather, and weather was one of the original uses for heat maps, and that's where heat map gets its name, because its original purpose was in tracking weather. So let's take a look at a few non-weather examples of a heat map. In this one, we're looking at new product sales of a company. And if you look there on the legend, it's looking at last year's sales. And so we got low sales would be in blue, yellowish is medium sales, and red is going to be high sales. So again, heat maps are very good because it's very visually easy to understand what's going on. Not very good sales in a place like that that's blue. White would indicate no sales at all. So there's a lot of blank spots on the map, which means no sales. But again, over here in this whole area, very low sales. Right here, pretty good sales. It's a lot of yellow surrounding and then red in the middle. And then again, you can move over to Dallas, very red, very good sales there. Chicago, Detroit, Ohio, and Philadelphia area, lots of sales around that area. So that's why heat maps are very effective. It's very easy to look at and see what's going on. Let's look at one more heat map. And this one's looking at gas prices in the U.S., and this is in March of 2019. So if you look down at the legend here, the way it's tracking gas prices is in dollars per gallon of gas. So $3.77 or higher is the highest in this case, and that's in bright red. It goes down a little bit. Middle range is yellowish. And then at the very bottom, if you see dark green, the darker green it is means the cheaper the gas is. So that's the heat map. And again, it's very easy to see what's going on here when you look at it. Right here in the south, this whole region here is very cheap. Everything is in green or yellow. And then you go up north a little bit, it starts to get a little bit more orange. But then when you go across to the west coast, we start to get real orange. And then the entire west coast is bright red. So you can just see the gas prices are most expensive on the west coast and cheapest in the south. So that is all the graphs of the day we're going over. The graphs are charts. Hope this video helped. Have a good day.